So this is the first page of HL addendum for continuous random variables, which is in the SL book known as normal distribution. Um, so in part A, we are going to set some definitions here. Blank is the value of x at the maximum value of f of x on the interval a to b. If you have a probability distribution and it kind of looks like this, then the x-axis value is x and the y-axis value is f of x. F of x corresponds to the relative probability that a value of x is going to occur. If we're talking about the maximum value of f of x, we're talking about this point right here. That is, of course, the mode. Okay, the mode is the x value, which corresponds to the highest peak there. The next one is m is the solution for m of the equation, and then there's an equation here where they do a integral from the left extreme of the interval to the value m, and if you do this integral from a to this value m, then it just so happens that that you get half of the area in this integral. And of course, if you have half of the probability on the left and half of the probability on the right, that corresponds to the median, right? Because the median has half the occurrences on the left and half the occurrences on the right. And then the next one is mu, or expected value of x is, and remember mu is just a symbol for the mean or average. And if you look at this formula here, that is a familiar formula to find the average of a continuous variable. So this would be mean or average. And the last one is the variance of x equals the expected value of the random variable x squared minus the mean squared. And this, of course, is just variance. And remember, variance is the square of standard deviation, right? Okay. Number one. Here's the probability distribution. F of x equals ax times x minus 4. You notice that they're giving us unknown constant there, a. We don't know what a is. The reason why they put a variable like that in there is to give us the first easy question that they're going to give us, which is they want us to normalize the probability distribution. So of course the total area of the probability distribution should equal to 1 because the probability of everything happening is 1. So what they want to do is they want to find the value of a, which makes the whole thing have the area add up to 1. And so they give us the extremes of the interval 0 to 4. And basically what you could do is you could say, okay, I am going to use an integral like the integrals that were done up here, except for what I'm going to do is I'm just going to take the integral of ax x minus 4 from 0 to 4 because those are the extremes, and I know that that should add up to 1. And when you do that, you're going to end up with an integral with a still in it, and then you're going to solve for a. So let's try that first. So to do the integral of this, it's easier if we just multiply it out first. So it would be ax squared minus 4ax, and then we're going to take the integral. And when we take the integral now, it'll be ax cubed divided by 3 minus 4ax squared divided by 2. And we're going to set that equal to 1 because we know that the probability of anything happening is equal to 1. Oh, and I forgot one thing. This is definite integral from 0 to 4. So let's plug in the 4 and the 0. If we plug in 0, everything's going to be 0. So all we need to do is plug in the 4. So we get a times 4 cubed divided by 3 minus, and so 4 times x squared would also be 4 cubed a divided by 2. And so if we take 4 cubed a, if we factor it out, we end up with 1/3 minus 1/2. And so basically that's equal to 4 cubed a it's equal to negative 1/6 equals 1. So let me just make a little bit more space here. Okay, and then I'm going to have 4 cubed is, I think it's 64. 4 times 4 is 16. 4 times 16, yeah, it's 64. 64 divided, so it's negative 64 divided by 16. So if I multiply everything out, I get negative 64 over 6, a equals 1. And if I want to solve for a, I get a equals negative 6 over 64. I could reduce that a little bit. I could put negative 3 over 32. Okay, so now I have a value for a. And with that value for a, I could do this step here, which is sketch the graph of y equals f of x. And so if I substitute a in, my new function is going to be a, negative 3 over 32, x squared, minus 4 times negative 3 over 32, which was negative minus 4, so it would be plus 12 over 32 times x. Now the part B, it asks us to sketch the graph of this function. I'm going to do it on the calculator, but if you wanted to, you could use negative b over 2a to find the vertex and graph it by hand. You could factor it to find the x-intercepts, etc. Let's see. I'm going to put negative 33 divided by 32 times x squared plus 12 over 32. Yay, Royals. Times x. And I'm going to graph. Okay, now I'm going to adjust my window so that I only see from x equals 0 to x equals 4, or x equals 5 or so. And then the y min could be 0, because I don't care about the negative y's, and I'll make the y max 10, and now let's regraph. Okay, so there it is. Now, for this distribution, find the mean, the mode, and the median. And do you see how, I'm going to adjust this window size just one more time. I'm going to do a zoom fit. When you do the zoom fit, you are going to see that the function is centered between 0 and 4. So the vertex happens to be at 2 comma something, right? So if the middle of a symmetrical PDF is here located at 2, then the mean is going to be 2, the mode is going to be 2, and the median is going to be 2, since it's symmetrical. Okay, because they all are located in the middle if you're talking about a symmetrical distribution. Okay, now let's go to variance. Variance is not so easy. All right, so let's take the equation for variance, which is we are going to take the expected value of x squared times the function. So we're going to have we're going to integrate from 0 to 4, which are the extremes, and then we're going to have the function inside the parentheses. And then we're going to multiply the function times x squared, because we're actually finding the expected value of the x squared. And then we need to subtract the mu squared. So mu squared is 2 squared. So now let's distribute the x squared to each one of these terms to get the thing as 2 terms added together. So it would be negative 3 over 32 x cubed, or x to the 4th actually, plus 12 over 32 x cubed dx minus 2 squared. Now we're going to integrate. So it would be minus 3 over 32 x to the 5th over 5. plus 12 over 32 x to the fourth divided by 4. 0 to 4 minus 4. And I am going to put 4 into each one of those x's, and then I'm going to put 0 into each one of those x's and subtract it. I don't need to put the zeros in because I'm just going to get a bunch of zeros out. So first I'm going to do minus 3 over 32, 4 to the fifth, divided by 5, plus 12 over 32, 4 to the fourth, over 4, minus 4. Okay, and let's do some simplification here. So I'm just going to use the calculator. Okay, so first I'm going to have 3 times 4 to the fifth divided by 32 divided by 5, 19.2. So the first term is negative 19.2. And then the second term would be 12 divided by 32 times 4 cubed. I divided 4 to the fourth divided by 4, and I get 24. So I have negative 19.2 plus 20, it's equal to 0.8. One last thing, I forgot to graph. So I've now entered this function, right? Then I graph it. And then I just do a adjustment so I can see it better. I'm just going to do a zoom fit. Oh, that was a bad idea. Let's adjust the window first. So the window is going to go x equals 0 to x equals 4. Then I'm going to do zoom fit. Okay. Now I just need to figure out how high that is so that I can mark it on the graph. So let's do a second calc. Maximum, left bound. Oops. Second calc, maximum, left bound. We'll move it over here a little bit. Enter. Right bound, we'll move it over here a little bit. Enter. So it's 3.375. So if I was going to draw the graph, it would be, oops, about there. This is 4, 5. Okay, and it gets up to about 0.375 there. All right, and from the graph, remember, we could see that it was a symmetrical distribution centered at 2. So that's how we knew that the mean, the mode, and the median were all 2. Moving on, number 3. So we have a more complicated looking distribution here, k e to the negative x, and it ranges from 0 to 3. And they want us to find k correct to 4 decimal places. This is always the first question they're going to ask. They're going to ask you to normalize the distribution. So what we want to know is, if we take the integral of the distribution from 0 to 3, because those are the extremes of the interval, it should equal to 1. So let's do that. We're going to take the derivative of that. So it's going to be k e to the negative x divided by negative 1. Which is just negative multiplied there. And we've taken the derivative, or taken the integral, so we can put the limits on the outside, and that equals to 1. And then we just substitute in the 3 and the 1. And so the first time we're going to put in the 3, it'll be k e to the negative 3. Then we're going to subtract the value if we plug in e to the 0, and that equals 1. Well, let's see. This is equal to k e to the 0 is k, so it's equal to plus k, right? And this one is going to be negative k e to the negative 3. So that's equal to 1. So we got k we're going to factor out k. We'll have 1 minus e to the negative 3 equals 1. So k is equal to 1 over 1 minus e to the negative 3. Okay. So if we want to find that as a decimal, we just put it in the calculator, but we could just leave it like that, right, on the exam. 1 minus e to the negative 3. One 1.052. 3. No, 1.0524. 1.0524. Find the median of the distribution. Okay, the median of the distribution is the middle of the distribution. Okay, so the distribution, remember, is like an exponential shape, so it kind of looks like this, and it just stops at 3. The median of the distribution is where half the area is to the left and half the area is to the right. So what we're going to do to find that is we're going to do a integral from 0 to m, and we don't know where m is exactly, and we're going to put in 1.0524 for k and e to the negative x, and then we're going to make that equal to 0.5 because the median half the area of 1. So now we're going to take the integral of 1.0524 e to the negative x, and we know that's going to be just negative 1.0524 e to the negative x with m and 0 here. And then we substitute it in m and 0, and then we're just going to get negative 1.0524 e to the negative m minus e to the 0, which is 1. And that is going to equal 0.5. And now divide both sides by negative 1.0524. And that'll give us negative 0.475. Negative 0.475. And here we still have e to the negative m minus 1. Add 1 to both sides. We have e to the negative m equals, add 1, it would be 1 minus 0.4751 gives us 0.525. Then we take the natural log of both sides. So that would be negative m equals the natural log of 0.525, which is equal to negative 0.645. And m is equal to 0.645. That's it.